Okay, what we're going to do here is do things that affect the width of the frame. We've already moved frames up and stretched frames up, and we've moved frames left and right. We haven't stretched them. Now we know from our previous experience with functions that putting a little number next to t here makes the function go up or down more faster or more slowly. But we need something that's a little bit more precise than that because we actually have to know how wide that frame is going to be. So here we go. First thing you're going to see, by the way, is that when k equals 1, the original width is 2 pi. So right away we see that k is not the width of the frame. When k equals 1, the frame is 2 pi. Just a general thing, if I make k bigger by just sliding, you can see that the frame gets not as wide. If I make k smaller, the frame gets much wider, right? So there's sort of this inverse relationship going on. The smaller k gets, the wider the frame. The bigger k gets, the less wide the frame. Now let's go back to 1. This is our normal sine graph. Now right here it says what happens when k equals 2. When k equals 2, I want to see what exactly happens to the frame. I'm just going to slide this up to 2 and hopefully it'll stay there like that. You can see that it got a lot smaller, but exactly how much smaller? Well, the frame went from 2 pi to 1 pi. So what happens when k equals 2? The width got divided by 2, the original width. What happens when k equals 3? Let's go like this. We're going to go over to k equals 3. You can see this thing. Yeah, in fact, you can see that it now goes, there's one period, another period, another period. It now goes through 3 whole periods from 0 to 2 pi, right? So what happens is the width of the frame got divided by 3. So putting a k there that was equal to 3, the original width got divided by 3. Now let's see what happens when k gets smaller instead of bigger. So we're going to go back to the original. When k equals 0, when k equals 1, we have our original sine graph. Now if I bring down k to by 0.1, let's see, 0.1, you can see that's getting bigger and bigger. Let's make it 0.5, not 0.1. That's a half. Now, when k is a half, the graph went up and down half as fast. Well, that made the width of the frame twice as big. So that's what I'm going to write down here. Yes, the original width got twice as big. I think we could say that now. How about this? The new width is twice as big as the original. Like that better. Yeah. What happens when k is a quarter? Well, when k is a quarter, I think it's going to go up even more slowly. I'm going to actually have to type in a quarter here, like this. And holy cow, now what happened, right? When k is a quarter, the width of the frame got 4 times as big. So I'm going to write this down, try the same way. The new width is now 4 times as big as the original. In other words, the new width is the original width. That was 2 pi divided by 1/4. So that wound up being our 8 pi, right? What does that tell us? You can see what I actually had to do here, and I did this every single time, is that the conclusion we want to be able to say is the new width of the frame is going to be the original width, 2 pi, divided by that number k that goes there. We're going to be using this formula a lot, so I would memorize it. Please.